So welcome to Physics 121. So this is chapter 1. This chapter is just purely conceptual. So I don't think you'll be doing any problems. No math! Well, I shouldn't say a little bit of math. So just concepts. We'll do the word problems next chapter. So chapter 1, concepts of motion. That's kind of like how the author writes his book. I mean, he spends a lot of time on the concepts, and then once you understand the concepts, then he starts introducing the equations and all that kind of thing. To understand and use the basic ideas of the particle model. So the particle model, I mean, that's just basically, we're going to, for quite a while, we're going to assume that everything we describe is just a particle. So it's represented by a point. I don't care if it's a car, a person, whatever, it's a point. To analyze the motion of an object by using motion diagrams, we'll talk about that a lot today, as a tool. To differentiate between the concepts of position, velocity, and acceleration. Most of you should already know that. This is a tough one, that's why I put it in yellow. To recognize the relationship between velocity and acceleration when an object is speeding up, slowing down, or at a turning point. Most people have completely incorrect concepts about that. To gain initial experience with graphical addition and subtraction of vectors, so adding and subtracting vectors graphically. To learn about position versus time graphs. To begin the process of learning to analyze problems and to translate the information into other representations, problem solving. To review unit conversions, like cubic meters to cubic centimeters or something like that. So I'm assuming that you've read the first few sections of the book. Okay. So what we're going to do again, for the third time, we're going to describe the motion of an object. So let's talk about this motion diagram. It's just a tool, but it's a super useful tool. So all it is, a motion diagram is a picture of an object's position at equally spaced time intervals. So here's an example. So let's say somebody in the back had a flash camera, which flashed every, I don't know, 1/10 of a second. And so if the room were dark and I were walking across the room, you would see me every 1/10 of a second. So that would be, that would be a motion diagram, okay? So again, it's a picture of an object's position at equally spaced time intervals. That's the important thing. Equally spaced time intervals. All right, so all we're going to do again is concepts, so no numbers, all right? Okay, so what I'm going to do, I'm going to walk across the room and just pretend you can only see me from here to here. So you can't see me over there. You can't see me over here. So what I want you to do, please, is grab a piece of paper and actually draw a motion diagram of me, all right? Starting there and ending there, okay? So there we go. All right, so draw a motion diagram. It's too bad we're not in class because I would have you work together with your neighbors, but oh well, you got to make the best of it, right? Okay, so let's see. You should have something like that. And it doesn't have to have 4 dots. And you don't have to label it 1, 2, 3, 4. You could say beginning and end. But what's the important thing? The important thing is that I was walking at a constant direction and a constant speed. So if these are equally spaced time intervals, this distance has to be the same as that, which has to be the same as that. That's all there is to it, okay? So, nice motion diagram, constant speed. Now, I don't have a whole lot of room in this room, but oh, whatever. We do our best, right? Okay, so now do the same thing. So get ready. Okay, remember, you stopped seeing me over here, so I was still going faster and faster. So draw the motion diagram. All right, give you a minute. Okay, so it should look something like that. again, equally spaced time intervals, right? So I was going slowly here, so I didn't cover much distance. Then I went faster and faster and faster. So that's the important thing. This distance here has to be longer than that distance, which has to be longer than that distance, because my speed was increasing. Right? Now you know what the next thing is, right? Oh, brother, there's a desk in the way. All right, ready? Okay, ready? Here we go. All right, so draw the motion diagram. If you need to pause your video, pause your video. Okay, so I was slowing down. So here, I was going quickly, so I covered a lot of distance in the same time as this, right? Same time, same time, same time. But here I was going quickly, then I was slowing down and slowing down. So there you go. So make sure you understand those motion diagrams, because they'll be useful to us when we start solving problems in chapter 2, in 3 and 4 and 5. All right. So this is one of those multiple choice questions I was telling you about when we had our introduction. So what you're supposed to do, you're supposed to read it and decide on an answer, or the answers. Sometimes there's more than one correct answer. For example, I'll be nice. There are 3 correct answers here. So read the question, think about it, and if we were in class, we would vote. Well, we can't vote now, and so just decide on which answers are correct. So pause your video and do it. Oh, let me say something first. You're not going to progress and you're not going to learn a whole lot if you just ignore what I say and just, keep watching the video and look at the answers. You have to learn to start thinking like a physicist. And you're only going to do that if you push yourself. So, all right? So pause your video and figure this out, and then start your video again. Okay, so we're back. All right, now notice this distance is the same as that, right? So the black ball is moving at constant speed. Well, look at this. That distance is the same as that. So the blue ball is also moving at a constant speed, all right? So the black ball has constant speed, blue ball has a constant speed. Now remember, equally spaced time intervals. So this one is obviously covering more distance in the same time as this one. So the blue guy, or the blue ball, is going faster. Well, of course, it doesn't say that. The black ball moves slower than the blue ball, okay? So there you go. Okay, here's another one. So read it and pause your video. Okay, let's answer it. Describe each ball's motion. Well, this looks to be constant motion, right? Because the distances are the same for the same time interval. But here, what's going on? Here, small, larger, 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 larger. So this one is going faster and faster and faster. So what are the answers? Okay, the black ball has an increasing speed, and the blue ball has a constant speed. All right, one more. So now you notice it's labeled A and B. That means it starts, up here and it ends down there, okay? So describe the ball's motion. So pause your video and figure it out. All right, we're back. And again, you can see that the distance for the same time is getting larger and larger and larger. So increasing speed, increasing speed. All right, now suppose we have call it an inclined plane. What's an inclined plane? It's a board that's slanted, all right? So this is just a board that's slanted. And let's say we ignore friction. So forget about friction. And we have a block of wood or something like that. And we're going to just hold the block of wood and then let it go, okay? So again, ignore friction. So what I want you to do is please draw the motion diagram for this block of wood, All right, so do that. All right, let's do it. Okay, so what's going to happen? If we're ignoring friction, you know it's going to go faster and faster and faster, right? And so that's what this shows, right? So the distance is getting longer and longer and longer. So the speed is increasing. All right, how about this? Oh, brother. So I'm going to throw this straight up. I hope it's straight up. So throw it straight up. Okay, so please draw the motion diagram just for the trip straight up. Okay? So after it leaves my hand, before it stops. All right? So draw the motion diagram after it leaves my hand, and well, you can go until it stops, whatever, that's fine. It's a real shame we're not in the class because it would be very useful for you to discuss this with your neighbors, but like I say, we make the best of it. Okay, so there it is. So what happens when you throw something up? It gets slower and slower and slower because of gravity. So, all right, so this is less than that, which is less than that, which is less than that. And again, you don't have to label it 1, 2, 3, 4 or A, B, C, D. You can just say beginning or end. All right? But anyway, that's the motion diagram. Okay, so that was just all concepts, right? We didn't even have any numbers. Or maybe we had a number to label it, but I mean, we didn't really do any math or anything like that. Okay, now what we want to do is we want to do quantitative. So we want to use numbers. So we want to have, make some measurements and things like that, okay? So think about it. If you're going to make measurements, remember we're trying to describe motion. If you're going to make measurements, you need some kind of a coordinate system because you've got to measure things, right? You need a coordinate system. So does that even show up? Okay, all right, good. So this is called a Cartesian coordinate system. That's what you probably use a lot in high school. You have your x-axis, you have your y-axis. Now most of the time, well, in fact, all of the time, we're going to always, so here's the origin. We're going to say that moving to the right is plus, moving to the left is minus, because you get to give direction. Most of the time, but not all the time, we're going to say going up is plus, going down is minus. And that's what you're used to, I'm sure, in high school. So that's what we're going to do. Now, just by the way, this is not the only coordinate system. I mean, if you are describing the position of an ant on the surface of a basketball, you'd be a crazy fool to use this kind of coordinate system because it would just be too difficult. What you'd probably want to use is something like this. These are called spherical coordinates. Or how about if you had a soda pop can and there was an ant on the soda pop can? You want to use cylindrical coordinates. We're not going to use these. Don't worry about it. I just wanted to show you that there's other coordinate systems besides this. And basically, you choose a coordinate system to make life easy. And that's why you do it, not to make life difficult, to make life easy. All right, so here's a question for you. Consider the motion diagram above. What can you say about it? So pause read it and pause your video and figure it out. All right. What can you say? I mean, you don't know where the beginning and the end are, right? So you don't know anything, right? So there's not enough information to decide because you don't know where the start is and where the end is. So you don't know the direction, right? So how do you indicate direction? You indicate direction with vectors. Now, I don't know if this is going to work, but let's try. It usually doesn't. Anyway, we'll see. So this is a little clip from the movie Despicable Me. I don't even know if it's, I haven't checked it for a while, so it might not even be valid anymore. Yeah, hold on.
I'm applying for a new film loan by the name of Vector. It's a
Hold on, just a
Pull on the gun! Oh yes! Fires light coronas. Ever seen one before? No, you haven't. I invented it. Doing a demonstration.
How come it? What's the deal here? Did you pause it or something?
No.
Oh,
Should I pause it?
can you? No, that's all right.
Club Wyndham owners have plenty of
No.
options.
Yeah, go pause it.
Over 220 resorts worldwide. So we made the search process simpler on the Club Wyndham website. There,